All right, let's go ahead and get started. Everybody enjoy lunch? Everybody excited about the iPhone 5C? You didn't hear earlier, did they announce the new iPhones today? 5C is coming out, it's a colored one. Yeah, whatever. All right, this is the batch talk about the JSR, so I'll get started. Who am I? My name is Michael Minella. I'm the author of Pro Spring Batch. I was on the expert group for JSR-352, and I'm the project lead for Spring Batch. You can reach me on Twitter. If you want to get a hold of me, Google me. I'm really easy to find. In short, I do a lot of batch work, though. Don't worry about taking notes or anything like that. All this is already out on GitHub. The presentation is actually HTML. It's hosted on GitHub, so I'm just browsing my GitHub page right now, and also all the code is already out there as well. In fact, you can find it here. If you've got the USB drive, you can find it that way as well. You've heard last night at the keynote and probably through presentations today about the Spring I/O platform. So batch obviously is one of the components in the foundation layer. XD is one of the projects that build in the execution layer that builds on top of batch. You can actually run batch jobs within Spring XD. And then Spring Boot is one of its goals is to make building batch applications easier. So what are we going to talk about today? We're going to talk about three things. First, we're going to talk about the JSR, obviously, right? Then we're going to talk about Spring Batch's implementation of the JSR. So what is Spring Batch bringing to the JSR spec? And finally, we're going to look at, or at least talk a little bit about how Spring Batch goes beyond the JSR. The JSR provides X functionality. Spring Batch provides X more. Some just baseline expectations on what's going on today. This is a Spring conference. I'm assuming everybody has a vague idea of Spring, Spring Beans, dependency injection, that type of stuff. But I'm also assuming a base understanding of Spring Batch. Quick show of hands. Has anybody in here not used or does not know anything about Spring Batch? If there is, I'll do a quick, wow, I was not expecting that. Okay. Good to keep that in mind. Okay, well then I'm going to do a little bit of a Spring Batch 101 as we get going. The biggest point in any of my talks, though, is ask questions when you have them. I'd much rather have a dialogue than talk at you guys for the next 90 minutes, and I'm sure you feel the same way. So JSR-352. Chris Vignola, who was the spec lead, put it this way in an article, that JSR-352 introduces an exciting new Java specification for building, deploying, and running batch applications. For the record, it is JSR-352. Everybody else today that has mentioned it has called it 356. I don't even know what JSR-356 is. Does anybody? Sockets. Seriously, 56 is sockets? 356? That'd be kind of funny. But so Spring heard about this JSR and got involved. We feel like we know a little bit about batch processing, so we did get involved. This is a graph of the distribution of the expert group. You can see IBM had two members, one of them being the spec lead. The only other company that had more than one member was Spring. Full disclosure, this is how the distribution ended. When the expert group began, there was really only one Spring member, that was Wayne Lund. And then I was an independent at the time, and I've since been hired on as Spring, so this graph represents that. But we've got involved because Spring Batch is a leader in the space. It probably is the most popular batch framework for the Java platform. In fact, not only the Java platform, but I also get requests about, are we talking about porting it over to .NET? There really isn't an equivalent in the .NET world. Really, outside of the mainframe world, there really isn't a comparable comparison to in batch processing. So what were the results of the spec? We went through this JCP process. We brought in experts from around the world, all kinds of different experiences, all kinds of different backgrounds, and we ended up with, on the left is the spec, on the right is our documentation. For section 7 of the spec, take Spring Batch, anywhere it's mentioned, and replace it with JSR-352, and you have word for word our documentation. Structurally, they're the same. What that means is the JSR has things like jobs. The job is a long-running or an extended process that's intended to run without interruption or interaction. Those jobs are divided up into steps. Those are smaller subunits of work that will execute serially, essentially. So step 1 will start, process, and finish. Steps 2 will start, run, and finish, etc. Each step has either a tasklet or a chunk-based step, which will do readers, processors, and writers. There's the concept of partitioning for multi-threaded jobs. There's flows and splits. So all the things that if you have played with Spring Batch that you're familiar with, you're going to find in the spec. But what does the spec specifically provide? It provides 3 things. It provides an API for building batch components. It provides a DSL for configuring these batch components, in other words, assembling them into jobs. And finally, it provides a contract of how those components are intended to interact. Remember these 3 points because they'll be important later on. Before I get into digging into code and the structure, let's talk about some high-level differences between Spring Batch and any other JSR implementation. This is a Spring Batch job, at least the configuration of it. You can see it's in XML. We start off with a job element. Within there, you can have 1 or more steps. Within each step, you can either have a reference to a tasklet or a chunk, in which case you'll have a reader, optionally a processor, and a writer, and then typically a commit interval. There's other things like listeners and other things that could be in there, but this is as basic of a batch job as you're probably ever going to see.
Sorry.
Yeah.
For those of us, again, who have never seen this before, what is a tasklet, what is a chunk?
So, good question. So there are 2 different types of step processing within Spring Batch. There is a tasklet step, which essentially runs a tasklet, which is an interface with a single method on it called execute. And basically, we're going to run whatever code you put in that execute method within the scope of a transaction. That's kind of the roll your own pattern, if you will. The other option is a chunk step, which has a reader, a processor, and a writer. And what happens is we're going to call those within a loop within the step. And let's say you've got 1,000,000 records to process. And you've got the commit interval at 1,000. We're going to read 1,000 records, we're going to process 1,000 records, and we're going to write 1,000 records, all within the scope of a transaction. Then we're going to repeat that over and over until we complete the step.
Reading all 1,000, you're reading one, you're doing each of those.
We read one, process 1 until we hit 1,000, then we write all at once.
And if a job fails, sorry, these questions are too detailed.
No, please do.
If a job fails, you talk about steps, and you've got a 5-step job, and it fails at step 4. Can you restart it at step 4?
Yes. Yes.
So the steps have to be basically atomic, so when the step is done, it's considered to be...
State is maintained within what's called the job repository. And the job repository, we offer 2 implementations, but it maintains the state both of the jobs and the steps. So what step are you on? Within the step, what chunks you've completed. And then depending on how you've configured the components, like a reader, if you have a flat file item reader, it may keep track of how many lines you've read, or database and what ID you got to, depending on how you configure it. Hmm? Any other questions about this before I move on? So like I said, this is a basic Spring Batch job. This is a basic JSR batch job. Again, we have a job element. We have a step element. We drop the tasklet element. We go straight to the chunk element. It's got an item count instead of a commit interval. It's got a reader, processor, and writer element. That's really it. When you compare them side by side, they look almost identical, right? So I'm going to spend the next 90 minutes debating the naming of commit interval versus item count and the differences between attributes and elements? Yeah, I don't think so. What is different? What is missing from the JSR side? Tasklet, yes. Something much bigger, though. Dependency injection. Dependency injection is a foundational technology that Spring Batch is built on, right? It's built on Spring. We inject dependencies into our batch components. We inject our batch components into factory beans that build our steps and build our jobs. All these things are built on dependency injection, yet JSR-352 does not require a dependency injection implementation. Specifically, a 299 or what is it, 330, the JSR-specific DI implementations. So when we look at this configuration for a batch job in the JSR world, I see reader ref equals item reader. I see processor ref equals item processor, and writer ref equals item writer. Where are those pointing to if dependency injection isn't a requirement? It's one of three places that it's pointing to. In the Spring world, you have the option of using Spring dependency injection and having it point to a Spring bean. The spec is written in a way that does not require dependency injection, but allows it. We explicitly wanted you to be able to use dependency injection, whether it be Spring, CDI, etc. Another option is there's a new configuration file called the batch.xml. We'll look at an example in a minute, but essentially what that does is it provides a mapping between names and class names. The last option is you can actually just drop the class name itself into that ref element and not even use any of these other options. So, yeah.
Are you saying that those are three places within the JSR or three places within Spring Batch?
Yes. The last two are JSR specific. The top one, the JSR explicitly says that the order of where we're going to look for those names is an implementation specific option, which in our case is Spring, then the batch.xml, then the class itself. Yeah.
Does it mandate XML, all the configuration in XML?
It does. So that's actually a good historical question. The expert group originally wanted to avoid XML. You know, XML has a bad taste in everybody's mouth. Even Dave Syer yesterday, who during the keynote mentioned that he loves it, but it's got a bad taste. In fact, we actually got from the executive committee for the JCP, we got pushback on using XML. What we tried before, though, is doing annotations only. That was the way everybody else wanted to do it. If you have tried to create a flow or describe a flow with annotations only, that gets really ugly really fast. We were getting annotation blocks, 15 and 20 lines long. And that was just for simple examples, not even, real enterprise jobs. So we punted on it. Full disclosure, in the future, I can definitely see some type of builder API being used. The caveat, though, there is, again, we don't have dependency injection. So what other option do we have? What other framework do we have for that building component? It gets complicated. So at least with Spring, we have the builder API within the Spring context that we can build off of. Whereas in a Java SE world, you don't have that. You don't have CDI. You don't have any of that. So with those configuration options, obviously everybody here has seen the Spring Bean. So this would be the Spring configuration option. You configure your Spring Beans just like anything else. This example is for a stacks event item writer, so this would be writing to XML. Option 2, like I said, is the batch.xml. So here you've got a batch artifacts element, and then you have a list of ref elements, each one having an ID and a fully qualified class name. That mapping is what you use in your job definition. So I would use item reader, processor, and writer in my job definitions somewhere else. This file is required to be located in the root of your class path. I'm sorry, root of the meta-inf directory of your class path. So we'll look in /meta-inf/batch.xml. There is no way to configure another location for this. The third option is just drop the class name in yourself. So this is the same job again. Now instead of having ref equals item reader, processor, and writer, I just have the fully qualified class names in here. That's perfectly acceptable within the spec. There's a caveat, yeah?
The last two methods, if you have some dependency information for those classes?
You read my mind. So the question was if there are dependencies upon these for the last two method options, the batch.xml and this one, what happens essentially, right? Yeah. Both of these options require default constructors, and the batch artifacts are responsible for pulling up their own dependencies. So if you have an item writer that needs a database connection, that item writer is responsible for getting a handle on the database connection, et cetera, et cetera. So yeah, it adds on quite a bit as you're developing these components. The other big difference is properties. Spring injects them on the bean definitions. So if I define a bean, you might have a list of properties, right? Property name, value, or name ref, right? Which one of the consequences of this is it leaves a pretty clean job description. So if you look at the definition of the job itself, all you see are the steps and the job, the steps, and what they and those dependencies. The JSR injects properties on the job definition. So now instead of having properties defined essentially like in the batch.xml, we actually, just about every element in the job definition takes a collection of properties elements to configure your properties. Let's look at an example. Oh, one other thing before I get to the example. JSR-352 are strings only for properties. So if you want to inject an int, if you want to inject, et cetera, you have to do all the cleanup and conversion yourself. So if we look at a Spring Batch job, and let's assume that this job has 3 parameters. It requires the commit interval, which we can see here in our job definition. But let's assume also, since we have a file reader and an XML writer, that we also need 2 references to file definitions, right? Here, the references to the file definitions are elsewhere, right? They're wherever I define the reader and writer. The same definition with JSR-352 gets a little bigger. That's because for my reader, I have a properties collection with a property with file name, value, and then same thing with the XML writer. Now you can see just within those 2 options, adding 2 parameters or 2 properties, that this suddenly made my XML significantly bigger. And you can imagine, if you think about the jobs you're probably running in your own enterprises, you're going to go from 20 lines of XML to a lot more. And also, at least for my opinion, the readability goes down a lot in order for me to see what's actually happening here, especially if I were to add some listeners with properties and et cetera. Deciphering through what's actually happening here gets hard. That's on the configuration side. On the flip side, in my batch artifact, I need the ability to receive that injection. Spring, it's via getters and setters, right? Or constructor args. With the JSR, we require annotations on your elements. Both annotations are required, both the inject and the batch property. But so this is how you would inject. This case, the first one would be file name. The second one, this could be anything. It takes a name attribute, and you can name that to be whatever you need it to be. Any questions on those 2 more global differences between the JSR and Spring Batch before we get into?
Yeah, right now Spring Batch 2.2 has annotations, right? It's based on annotations. So,
Well, some of the things are annotation based. I think what you're getting is it has Java config, right? The builders and that, right?
job configurations and all that many of them are annotation based, right?
Not annotation based. We have builders for them. Like there's a job builder, and you add steps and that. But you can't define a job just with annotations.
So this will be coming in Spring Batch 3.0, right? JSR-352.
Yes.
Yeah, so how is it going to change with whatever 2.2 you have? Is it going to change in 3.2, or you are going to continue what is there in 2.2 and merge it?
Let me come back to that one. Remind me when I get to the Spring part of it, but let me come back to that one. Right?
So you showed the properties being, you had to put the JSR, you had to put the properties for where you associate the reader or whatever.
Yep.
Can you, if your properties are somewhat static, can you include that in wherever the definition of the reader, the definition of that, the file reader is? Or is it only in this place where it's being connected to the chunk?
You're talking about, so when you say wherever I define the file reader, you mean if you're using Spring DI or if you're using the batch.xml or?
Batch.xml.
There's no way to define anything else in that batch.xml. That file I showed you, this is a complete batch.xml. These are all the elements that are allowed. There's nothing else you can put in here.
Okay, so basically scope or step is gone.
Another good question. So actually flip that. Everything is step scoped. So basically all your batch artifacts are step scoped now within the JSR. So for those new to Spring Batch, step scoped is basically lazily initialized beans that don't get initialized until the step begins. So if I've started a job and it's got 10 steps, everything to build out the structure of the job for those 10 steps are proxies until we need them. And then once we execute the step, then we actually instantiate the bean, populate the properties, and so on. So the JSR, the way we've worked it since we have the step scope, we've actually, basically everything's going to be step scoped. Other questions about these more general differences? Cool. I figured the best way to do this would be kind of dig in and build a little app. We're going to build an app, though, based on this video. Let's watch the video. So a little bit about this video. It was shot in 2003 by a couple kids, posted on the internet. And then within the first 2 weeks, it was downloaded over 1.1 million times. Now, when you think about 2003, nowadays you hear a video downloaded a million times. Yeah, okay, big deal. Everything on YouTube is downloaded a million times. But in 2003, let's think about how the state of technology. A 30 gig iPod cost $500 then. In 2003, MySpace just came out. Zuckerberg was in Harvard and wouldn't start coding Facebook until the next year, 2004. And most importantly, YouTube wouldn't exist till 2005, 2 years later. So to give you an idea, a video, especially of made in the basement of some kid's house, to get 1.1 million downloads in 2 weeks, that was pretty impressive in 2003. For full disclosure, this wasn't the original video. The original videos, that was 30 seconds. The original one's a minute and a half long, and it doesn't have the special effects or the music, but I like this version better. So, like I said, it was released in 2003, 1.1 million downloads. Since then, since it has made it to YouTube, it's been downloaded over 40 million times on YouTube. But in 2008, the guy that posted it on his website released the Apache logs for the first 6 months it was on. So we could actually see the downloads that were happening. And when you think about 2003, doing things like log analysis, that all the things everybody's talking about today or this conference, right? Spring Hadoop, Spring XD, big data. That's what they're talking about now, is analyzing this kind of data. Doing that back in 2003 wasn't possible. So in 2008, like I said, the guy released the Apache logs. The file's 1.6 gig zipped, or unzipped. It's about 2.25 or 250 megabytes zipped. You can download it via BitTorrent. There's a link in the presentation if you want to the article that talks about it. Those are the original file names. But what I want to know is who's watching this video. Are we Americans, or I'm sorry, I know this is an international audience. I'm an American. Are we Americans the only ones watching this cheesy stuff, or is this a worldwide thing? I wanted to know this. So what we're going to do is we're going to build a job. And this job is going to figure out who is watching this video. We're going to create a 3-step job. First step is a split. Now, the job we're going to build doesn't actually use the split. It's something that in the future we would be able to use. I'll explain why in a bit. But what we're going to do is we're going to take the file we're going to use and we're going to split it up into smaller files. The second step is we're going to import it into a database. So we're going to have a reader, an item processor, and a writer. The reader will read the files. The processor will actually geocode them. So it'll pull the IP address out of the log file, and it'll geocode that IP address. So it'll give us basically the country that the IP address was accessed from. Finally, like I said, we'll write it into a database. And then the last part is we'll generate a little HTML report that has a map with some pretty colors on it that highlights which countries were actually viewing this data. Does that make sense? So as we talked earlier, there are really two different types of step processing models. These are the same two that are in Spring Batch. They came over with the JSR. The first one is a batchlet step. Not a tasklet step, a batchlet step. That's one of the differences between the JSR and Spring Batch. It's been named a batchlet instead of a tasklet. It's the same thing. A batchlet equals a stoppable tasklet. Wait a minute. Stoppable tasklet. What the heck's that? That doesn't exist, right? Well, actually, it does in 3.0. 3.0, we've introduced the concept of a stoppable tasklet. Essentially what it is we've extended the tasklet interface to add a stop method. That stop method, what it does is it provides a hook for a long-running tasklet for the runtime to issue a request to a long-running tasklet to stop. So if I have a tasklet that's running, in an infinite loop, each iteration of that loop, it could be checking a Boolean, and then if I say job operator.stop, we'll call the stop method, which could, in theory, update a Boolean that's being checked every loop in the tasklet, and then the tasklet would know to stop. Basically provides an API for you guys a hook for you to stop it gracefully.
How does it do it now? Like if you spring batch-admin and you tell it to stop.
So batch-admin or using the job operator, if you say stop on it, all it does is it updates the job repository status. It's up to the tasklet then to be checking, basically. For the chunk type step, every time we loop through a chunk, we check that state. But if you write a tasklet, it's up to you to maintain or to monitor that. So like I said, the tasklet, we've got a regular tasklet and stop. The interface via the JSR is process and stop. It's functionally the same thing. So let's take a look at how we would split that file. Oops. Hello. Oops, wrong one. So I'll start off with the Java code, and then we can go into the configuration. So I've got a batchlet. I've got the file splitting batchlet. Oops, hold on. I need to get on the right branch. That'll be better. And we're back. Everybody see that all right? Is that big enough for those in the back? Seeing vague head nods? Okay. So the file splitting batchlet, what it's going to do is it's going to take in a file name and a number of lines in a string. That's the way the JSR works. And then we'll split the file based on the number of lines that are passed in. Process, I've got two methods. I've got an init and a split file. The init, basically all it does is it does the checks to make sure that my properties were set, and then it also does the integer parsing so I can actually use the string that was injected. The split file, while Spring Batch, you could use it to split a file by having a reader and a writer and piping it through. Performance-wise, while that's not bad, it's just not as good as split at the command line. So I'm just going to use that. So I do a little formatting of my input with regards to the file name. Then I'm just formatting the split command. -A is the number of characters in the file name. So in this case, it's going to be a 5-character file name. And then L is the number of lines. And then I've got the file name and the output directory. So the file name to be split, and then the directory to where you put all the divided up files. I'm going to run this as a future task so that it runs in the background essentially. So call. The only thing I'm doing here is I'm getting the directory to run it from. I'm not passing any environment parameters, and I'm passing in the command, which, like I said, was that split command. And then down below, This is just loop checking. Is it done yet? Is it done yet? Is it done yet? Until for 15 seconds. After 15 seconds, it'll time out and it'll die. Otherwise, once it's done, it'll shut down my executor and we'll move on. Yeah.
Number of lines is the only way to split, or you can use some other options?
The split command line also does bytes. So. So that's the batchlet itself. Let's take a look at the configuration. So we talked about the batch.xml needs to be in the root of the meta-inf directory. Batch jobs need to be located within the meta-inf batch jobs directory. Okay. Yeah.
Looking with the code, so basically you have the batch itself.
Mhm.
Batch is spreadable, right?
In this case, yes, yes.
So my question is, does the Spring Batch framework offer the basically capability that, oh, I want to do this job, create 5 specs for me to run this job?
Yes, and we'll get to that in a bit. So yeah, like I was saying, the batch job per the JSR needs to be located within meta-inf batch jobs and then some name.xml. Each one of these files can only have a single job definition. Okay, so if you're used to configuring Spring batch jobs and having maybe multiple jobs within the same context, and then just using the ID to figure out which job to execute, it doesn't work that way with the JSR. The JSR is going to load in the XML file you ask for, and whatever job is in there is going to be the one it runs.
Can you have subfolders there?
No. But what you can do is if you wanted to have if you wanted to use Spring DI, like I said you could earlier on, you could put basically your root context configuration in this directory, but you could then import other stuff down the line. And that you could organize however you want, because then you're coming to the Spring world. So if we look at, actually let's create a new one. New. XML file, download XML. I'm just going to steal this, save me some typing. So here's the configuration for my job as it sits right now. So I've got a job, it's called log analysis. You'll notice that it's in the file name demo.xml. It actually doesn't matter. There's no association required for the JSR between that ID and the file name. With the JSR, it's the file name that matters, not the ID. Then right now, this is a single step job to split. I'm calling my tasklet, or my batchlet. You'll notice I'm just dropping in the file name. I'm being lazy. I don't want to create a batch.xml. If anybody really wants me to, I can. And then you can see I'm injecting 2 properties. The file name, so I'll be pulling out of my job parameters the input file name, and then I just hard-coded 10,000 lines for my file to be chopped up. Any questions on any of that code?
Which one, file splitting is already available ready-made, right, in the Spring Batch?
You're just blowing half of my talk. Yes, there is, and we'll get to that later. Yeah. So is there any other questions, though, about the code, the configuration? I'm sure you guys are wondering, can we see it run, right? Let's talk about how you actually run a job in the JSR before we actually get to that. Whoa. I won't even go to presenter mode for this. So to launch a job, there is a single interface called the job operator within the JSR. That is the entry point to batch launching and management within the JSR. It's essentially a combination of our job operator and job explorer interfaces. They took both those interfaces and combined them into a single interface. But to launch a job, first we need a handle on the job operator. And we do that via batch runtime.getJobOperator. Batch runtime is basically just a factory that is going to load the job operator. In reality, behind the scenes, all it's using is Java service loader. So it's using the service loader API in Java to load in an instance. When we do that, for our Spring implementation, we are going to set up a base context for you with a number of defaults. So we're going to set up a job repository instance for you. We're going to set up a step scope for you. We're going to set up, obviously, the job operator for you. There's a number of things that by default we're just going to give you out of the box. It's very similar. You were mentioning the annotations in 2.2. It's very similar. The context is almost exactly the same as the enable batch processing annotation. When you use the enable batch processing annotation, there's a whole bunch of defaults we provide out of the box. The context you get out of the box with this job operator is very, very similar. You're able, using Spring, to override anything we do, but this just allows you to be able to execute a job literally with just 2 lines. Get your job operator and job operator.start, passing in the name of the XML file and any properties you have. No other code's required. Does that make sense? The important thing with the job operator, the start method, is this my job. In our case, will be demo. This is the name minus the .xml of the file to look for the job in. This isn't the name of the job. This is no relationship to any of the XML elements. This is purely the name of the file minus the .xml. This method, the other thing to note is normally within Spring Batch you've got a job parameters object that has some nice utility methods, but since everything is strings in the JSR, they just decided to go with a properties object. So parameters are actually passed in as a Java util properties object. Start returns the ID of the execution, of the job execution. For those of you who are new to Spring Batch, when you look in the job repository, you'll see 3 basic concepts: a job instance, a job execution, and a step execution. The job execution is essentially a logical run, or represents a logical run. So if I have a batch job that's going to run once a day, Monday, Tuesday, Wednesday, Thursday, etc., each one of those runs should get 1 job instance. That job may fail once in a while, right? Let's say Tuesday it fails, and I need to run it again. Every physical run is a job execution. So job instance has multiple job executions. When I run a job, obviously there's steps within there. Each step, as it's launched, will create its own step execution. Same concept as a job execution, only it's for the step level. These executions are what are used to maintain the state as the job is processing. So we use the job executions and the step executions on restart to figure out, okay, you were at step 3, you had finished 5,000 records, I need to pick up at 5,001 on step 3. Does that make sense? So like I was saying, when you start a job with the JSR, you get the job execution ID back. To restart or stop a job, you pass in the ID. Stop, that's all you need, obviously. For restart, you're also able to reset the properties to whatever you need them to be. Does that make sense? So if we look at the main class I put together to run this job, it's really complicated. Oops. So main method, batch runtime.getJobOperator, just from my slide. I'm creating a properties object. I'm establishing an execution ID for later. The execution ID, basically this is a main class that I could use either to start or restart a job. If you're restarting a job, at least with this main class, the first parameter would be assumed to be the execution ID. So I'm checking, is the first one the execution ID? Then I'm going to parse through the rest of the parameters. All I'm expecting is name equals value, just a list of those. And then if there wasn't an execution ID, or I'm sorry, if there was, we'll restart it. Otherwise, we will just start your job. Let's see if this thing actually runs. Hope it does. Starting clean. All right. Demo. Input file equals temp to be small. Actually, we don't even need that yet. Let's run that. Woo! It ran. And if we look, so that's the file so really quick, let me show the file that I'm processing. So this is the actual log file that I'm processing. For the record, the one we'll be running today in here is a abridged version. I took like the first, I think, 1,000 or 10,000 lines out of it, just so we don't have to sit through all 9 million rows processing. But it's your typical Apache log, right? You've got, starts off with an IP address, a date, the get, so get and then the URL, and then HP, status code, blah, blah, blah. What we're going to pull out of it is we're going to pull out the IP address, the timestamp, and then the URL that was requested as we process it. So in this case, we only end up with a single chunk because the file's small enough, but that's, yay, that's the result of that splitting. In fact, I can even do it again just to show. So, oops. So nothing up my sleeve. Run it again. I got a file. Ooh. All right. Questions about batch steps or the job operator before I move on? The JSR, so actually that's another good question. So the question was, where's the job repository within the JSR? The JSR requires that there be one that exists, but it has no specifications about what it is. So depending on who you go with, depending on what implementation you use, it could be anything. You know, I could write a JSR implementation that is file-based for a repository. I could have a database, or it could be anything. Yep, there is no specification about what the repository needs or how it functions. The only requirement is that you need to be able to maintain state for restartability. What you do with that's your business. With Spring Batch, there's the two options. There's the JDBC option, and then we have an in-memory map option as well. Yeah.
Is there an incrementer? I noticed that there wasn't one set on the stack.
There is not, and there's a reason for that. In Spring Batch, at least historically, parameters have been used as identifying job instances, right? In 2.2, we actually dropped that requirement. Now you can have non-identifying job parameters. With the JSR, all parameters are non-identifying. There's no such thing as an identifying parameter with the JSR. Every time I call job operator.start, I'm going to get a new job instance. So because of that, there really isn't a need for the incrementer. Right. Pardon? What? How? Well, that's because we're returning the database ID. For us, it's a database ID. Yeah, this is built, so I'm using the Spring Batch implementation for these demos. So for behind the scenes for us, we're using the database. They specify that that job execution ID is a long. How you get that is your problem. Exactly. I'm sorry, it's my problem.
Job launching is in there.
It's not part of the spec. It's not a JSR component. The job operator uses it behind the scenes. It's available as part of that base context that we create for you, but it's not part of the spec, so it's not something we expose openly. Let's put it that way.
So it's only job operator.
For JSR compliance, yes. Anything else before going on? So we talked about batch processing. Now let's get to the chunk side of the world. Time for a little truth, little confession with Spring Batch. If you're familiar with Spring Batch, you've probably seen a sequence diagram that looks like this. This is how our documentation reads about processing chunks. You had a reader, a processor, and a writer. For each chunk, for each item, we read the item, pass it to the processor, process the item, and then we hold it until all of the all the items within the chunk have been processed. We then call write once, writing all of the items within the chunk out at once. That's a lie. That is not how Spring Batch works under the covers. What Spring Batch really does is this. We still have a reader, a processor, a writer. I'm abstracting out the components that make all this magic happen behind the scenes. But until the item count is reached, we read. So we don't read and process, we read. Once we're done, once we hit the commit interval or until the completion policy is triggered, we read. Then we take that list and we go to the processor and we loop through that list processing until we've looped through all of the items that were read. Once that loop is done, then we take basically everything that the processor returned, because you can use a processor to filter. If it returns null, obviously it doesn't get written. But then we take that list and then we do the single call to the write. The reason Spring Batch, there is a reason we've been doing this, I promise. The reason is fault tolerance. By doing this method, if something goes wrong in the write, we've cached the reads. So we can then go back and essentially re-execute these. So if you've got a chunk of 1,000 items, if something goes wrong in the write, we can kick back, drop the the commit interval down to 1, and just reprocess them and write them one at a time until we find the one that actually broke it. That's the reason we do that. If you actually dig through the code, you'll see things about scanning. That's what's actually happening. The JS, yeah.
If it does really fail, how do we do that? How do I use the cache data and write it?
You don't. It's all behind the scenes.
So I just start the batch again?
Yeah. The batch will recover at the chunk boundary. So all of the rolling or starting back to the beginning of the chunk and going one at a time, that's all behind the scenes, because if when you restart, we're going to start at the beginning of that chunk anyways. The only reason we do this is so if something fails in that write you've got a collection of 1,000 items, we can say item 526 was the one that caused the problem.
Like you said, sentence, like if you had like 10,000 items that on your read would be like 10,000 items taken up each.
Yes. For the record, it would anyways, either processing option, because we're still going to hold them once the processor is done for the write.
I've seen, I think with like list iterator, like batches list iterator, they explicitly remove, they're iterating through like the list, like using JDBC template, they cast it to list iterator. This is different.
Yeah.
And the reason why it's done this way in Spring Batch is to help with the error reporting.
That's exactly right. Yeah. In fact, I'm trying to remember. I think is it the chunk listener or the write listener? One of the two. The error method Instead of taking the full collection, it takes the individual item because we can identify which item that is. Yeah.
So if it fails at any time in the chunk, or entire chunk processing, it won't cancel?
That is correct. Yeah, the whole thing is still within the same transaction. All great questions. The reason we do that, the reason we structure it this way, yeah, is because we pass in the whole collection at once. Because otherwise there's, well, I'd have to think about it. I know there's a reason, I'm drawing a blank on why. Sorry, the question was why do we reprocess them if the error happened in the write? So the JSR though takes our documentation literally. Remember how I said they copied our documentation? Oh, yeah, they took us literally. So their pattern is the way our documentation reads, which is for each chunk, for each item, we're going to read, process, hold, and then pass in all the items within a chunk at once. Now, I explained why Spring Batch does that. It does it our way. You actually lose that functionality in the JSR way. The listener involved in this, the listener involved in the error catching here only gets the list of items, and there's no indicator of which item caused the fail. It's up to you when you throw the exception to have some type of information within that exception to determine which item caused the exception. That's why. So like I said, there's a method to our madness, and this is the reason we did it.
So, I mean, observing the variations between the JSR and the way Spring Batch was implemented. So, especially this particular slide and the one before, where you have a different implementation in the way the chunk is processed. You know, you read a chunk, you process a chunk, and then you write the
Yep.
one writes.
Yep.
Are you guys going to be changing your approach to conform, to be in conformance with this JSR, or what's going to happen there?
I think you asked the similar question earlier on. Hold on until I get to the Spring piece of it. Any other questions on chunk processing and how all the pieces work before I move on to all awesome questions?
Is there a concept of remote chunking via JSR, or is that later?
I'm glad I cover all these slides later. Yes, that is later. Chunk-related interfaces. So, reader, processor, writer, these should all look familiar. They are the same type of interface as in Spring Batch. The big difference, though, is the reader and writer. In Spring Batch, the item reader interface has a single method, read on it. And the item writer has a single method, write on it. We have a separate interface called item stream that you can implement if you want to maintain state. That has the open, the update, and the close on it. The JSR combined them. So the item reader has the open, close, and in their case it's called update, or I'm sorry, called checkpoint, but it's functionally the same thing. Same with the item writer. When we brought up the idea of not wanting to require those methods to be implemented, the response we got was abstract classes instead. So the JSR provides abstract classes that you can extend instead of implementing these interfaces. That essentially these abstract classes provide nothing more than a bunch of no-ops. And the only required method is the read and the write, with everything else being no-ops. Checkpoints. So in the Spring Batch world, you hear about commit interval. The checkpoint is the equivalent in the JSR world. You can either do it via item or custom. The one caveat here is there's an additional attribute to configuring your checkpoint, which is timeouts. In the EE world, they allow you to configure transaction timeouts via the job as well. So let's take a look at the step 2 code. How are we doing time? Oops. So let's start off with the reader. Item reader. Don't need that anymore. I'll need that. Don't need that. Okay, so I've got a log reading item reader. It takes in a single property, the directory name. This is the directory of where the previous step wrote out all the stuff. I've got some file I/O stuff, so buffer reader. So there are two reasons I'm splitting the file. One is long term I'd like to be able to do this step multi-threaded. The other reason though is for restartability. I'm configuring the job to the commit interval to be the same as the size of the files. So what I'm doing is I'm going to process a file per transaction. That makes the maintenance of that state really easy. All I need to do is keep track of which files I've processed. As long as I keep track of that and I don't reprocess the same files, life is good. So it's the lazy man's way of keeping track of what stuff was processed. And I'm a developer, I'm lazy. So this hash set and set. These are the files read and files to read. So these are the files read are the ones that I've already processed. The files to read are the ones that I'm going to process. Keeping track of the current file. I'm using a regular expression to parse each record. This is a long regular expression, but essentially it's pulling out, like I said, the IP address, the date, and the file that was requested. So I mentioned that a reader requires these methods already, sorry, let me back it up. So this is implementing JavaX batch API chunk item reader. So I'm implementing the interface because I actually am going to maintain state here. So on open, I'm going to see if there was a collection that was previously processed. You'll notice our open, instead of taking an execution context like Spring Batch does, it takes just a serializable. The checkpoints within the JSR, instead of you updating a common context object that is known, you just provide what piece of data should be persisted. So this can be anything that's serializable. When the chunk commits, you provide that serializable as that's what the state, that is what represents the state. When we open it again on a restart, we'll provide that back to you to reset the state. Does that make sense? So in this case, the state is really the map of files I've already read. So I'm checking if there was one, recreate it. If there wasn't one, create one. I'm then going to get the list of the files in the directory that I'm going to process. I'm going to add the name of files to the files to read, and then I'm going to remove all the files that I've processed before. Close. All I need to do is close the reader. So when I read an item, while file, this is basically a while loop that's going to loop through all those files. So while there are still files to be read, if I haven't already opened up the file, go ahead and open it. I'm going to go ahead and read the line, and I'm going to parse the line. I'm going to parse the line if their line was returned. If there wasn't, I'm going to assume that this file is done and I should continue on to the next file. Parse the line. Move down. All this does is uses, the Java regular expression magic to parse the line. So I match on the regular expression. I pull out the first group for the IP address. I'm parsing the second group into a data object, and then the third group is the requested URL. I know. I know. But I'm not doing the multi-threaded right now anyway, so I'm safe. So that's the reader. Let's take a look at the processor. So the processor is going to do the geocoding. It's actually pretty simple. It's a cool API. I think it's called, is it MaxMind, MindMax, something like that? MaxMind. So this is actually just a jar file in my class path that has these mappings in memory. So it's actually pretty sweet. That's the file that has the mappings. Like I said, when I create this, it'll load it all in memory. But all I'm going to do is for each item, I'm going to get an IP address, and then I'm going to get, that'll return me a country, and then I'm going to get the country code out of that and store it. So, and a little bit. So reader is that max mine component, dot country for that IP address. Get country, get ISO code. ISO code is the 3-digit code that, I'm sorry, the 2-digit code that representing the country that the IP was located in. That's pretty much it for that. That's the processor, and let's take a look at the writer. So the writer, I'm writing to a database. If you download the code automatically or out of GitHub, if you just run it, it'll run with HSQLDB. Otherwise, there's also configuration there for MySQL if you want it. You'd have to change the username and password. But so writer, we need to open up our connection. There's really nothing here to manage as far as state goes, because if it fails within the middle of a chunk, it's going to roll back the transaction anyway. So and there's nothing for me to restart as far as state goes. So I just create my connection. In this case, I'm going to create my prepared statement, which is just insert into my database table the values. Nothing exciting here. Then for my write, again, nothing exciting here. I'm just going to loop through the items I received, assuming that I received some. For each one, I'll set the elements on the string, set the date, add it to a batch, and then I'll execute the prepared statement batch update. So a single shot.
Quick question on the abstract item processor and item writer for JSR. Does it do anything with generics like the Spring Batch version?
There are virtually no generics in the JSR. So the only other component that we're using here, no, I'm sorry, I'm using that in the next step, so I'll punt on that. So let's go ahead and configure this step. Item count, 10,000. Actually, let's just do this the easy way. So you guys don't have to correct my typing. Count this up for now. That for the same reason yet. Okay, so this is the configuration side of the second step. So you'll notice I added the next on the first step, just like Spring Batch. You can also use the transition elements like you normally would in Spring Batch. The only difference between those transition elements and the JSR is, I believe it's a stop one. They added the ability to map the exit code that the step provides to a new value here. We already allow that on fail. I think stop was the new one. But in this case, I'm just using the next shortcut. So next import, come down to import. Chunk item count equals 10,000. Like I said, it's the same size as my file size. Just referencing the reader. In this case, my directory name is going to be staging directory, which would be the directory that the first guy used or puts the stuff in, and then a processor and a writer. These guys don't have any parameters. Questions on any of that stuff?
Would you normally want to put the staging directory job parameter also in the first step?
Sorry, what?
Wouldn't you want to add that job parameter staging directory to the first step also?
Yeah, if I didn't add that parameter later on, it would be there. Instead, right now, it's actually hard-coded within the code. All right. So let me go ahead and clear this out again. And now I need to add that staging directory. That should be it. Cool, they're in. I didn't clear out my database, so, but I can do this. So, no, that's the wrong file or record anyways. I ran the full job with the full 1.6 gig file last night, so it's kind of big right now. So that's 7.37 blah, blah, blah. Let me run it one more time just to show that it does go up. Oh, sorry, that's why it's not showing up here. I'm using HSQLDB here, so it's all in memory. That's why. Sorry. You'll see it in the report in just a second. Questions on chunk-based processing before we move on to...
With each chunk, does it go on to the next step, or does it wait for all the chunks to be completed?
Each step has to be complete before you move on. So all the chunks within the step need to be processed before the next step will execute.
Can you skip any one of the items in the chunk and proceed further?
Pardon?
Can you skip any one of the items in the chunk? Say, for example, we have 10,000 records in a file, and say, second 10th or 14th record is not good, we do a validation process, and we ignore that and proceed further.
What do you say we try that? Let's add in a bad record. So first I'll delete my data. Then so let's add in, I have no idea where I'm at. That seems like a bad record to me. So first let's prove that it fails. Failed, bad. Why'd it fail? Go through the stack trace. Illegal state exception, no match found. So when I tried to parse with my regular expression, it blew up, as we expected. So I want to skip that record. This batch job's run in the middle of the night. That means I got a pager. That means I don't want to be woken up because of some idiot typed something in my file. So let's add skipping. Let's talk about that. Error handling. I swear you guys have all seen my deck. You're just taking all the fun out of this. Error handling. So there really are 3 different ways of handling errors. We already talked about one, which is restarting the job. Obviously, that doesn't do anything, though, if you haven't fixed the error. Otherwise, there are 2 additional options. Number 1 is skipping the record. Essentially, what you do is you configure the exceptions you want to skip. So in this case, we'll skip illegal state exceptions. And then you can also optionally configure a skip limit. So in this case, if you have a large file of 1 million records, and if you're skipping 10,000 records, chances are you just have a corrupt file as opposed to something else is wrong. So you probably want to abort then. So we offer that as well. So that's skipping. You also have the ability to retry. Same concept. You're configuring exceptions for things you want to retry. This is a scenario where things might, if you try again, something else might change. You may have a RESTful web service that you're calling that may have a network hiccup in the middle of the night. You may have optimistic locking failures. So if you just try updating that record again, it may pass this time. Okay. But those are the 3 main error handling options within the JSR. One point with retries. Spring Batch has not supported retries historically on the read. The reason for that is because most of our readers are stateful and forward moving. So to create a reader that allows you to retry on a resource that is forward moving only, like a JDBC cursor, so I've got a result set and I can only go forward, it's really hard to get something that allows you to retry reading that record from the cursor. So because of that, Spring Batch has just kind of said, you know what, we're not even going to try it. The JSR does allow retries on the readers. With Spring Batch 3.0, we'll go through item by or reader by reader and note this in the documentation, but assume that most of our readers, if they are stateful, will not support reader retry. They haven't historically, so we're not pulling the rug out from under you guys. This is just the same functionality. Yeah.
So when you do the skipping, can we get the notification? So can we get the notification when the record is skipped?
Yeah, so there's a skip listener that you can use. Actually, you were in Gunner's talk earlier, weren't you? So you could use the Spring integration techniques he showed with the listener with restarting the job. You could have that send an email as well for items that were skipped. Or you can also, really common thing is just writing that skipped record out to another file, so that when somebody gets in the morning, they can just go through that file, fix all the problems, and rerun the job. So you could use a file adapter on the outbound side to then just dump all that stuff with Spring integration. I got your back, man. So like I said, I just added a bum record, so let's actually configure this so it will skip. So just like Spring Batch, there's two different elements in the skip and the retry. There's include and exclude. Include is include this exception and everything. All of its subclasses. Exclude is, take any exception but this. So we're going to include an illegal state exception, which is, thank you. And I'm going to allow it to skip 10 times. If we skip more than 10 records, something's wrong with the file, I want to know about it, stop the job. So I cleared out my input, build successful. Run the job again. This time we should get the exception. It should still pass. Oh, import failed. Why? Now what? Why is it one more? Yeah, I see that. I'm wondering. I only added one bad record, unless it's parsing that differently than expected. For this demo, let's just crank it up. It's building. There you go. You can complete that time. So, oh, I know why. No, I'm not sure. All right, I'll have to look at that later. So scaling within, well, before I get to that, let me actually, let's finish this job. Oops. So there is one more step. Let's just go through it real quick, because it doesn't have any impact on the rest of the slides. It's just a cool step. So the last step is just a single batchlet. Report batchlet. So this batchlet, in the process method, I'm going to execute a query. Basically, it's going to do a select count grouping by country code. So it's going to give me country codes and the number of times, number of records that it found. For each one of those, I have to do this goofy mapping. The report I'm generating, I'm going to build out a map. And the API I'm using uses different country codes than what I get from the geolocation API. So I need to map those together. So that's what this country code mapper does. It's all hard-coded, so when I give you line counts later, 300 lines of this is just hard-coded junk. So just know that. But all I'm doing here is mapping the country code, and then I'm also going to just scale the, oh no, I already did that part, right? Yeah, I already did that part in the other one, never mind. And then I'm just using a FreeMarker to generate an HTML template, or an HTML report. Make it nice and pretty. So that's it. Oh yeah, here's the scaling part. The other part is, to make the colors somewhat interesting, I'm using a log scale. So this scale method, all it does is it scales the numbers from in a log scale instead of linear. Questions on this batchlet? All right, let's run this job. Clear out the data really quick. Oops. So same parameters, it's all fine. It's gonna run through. Completed, yay. And then, let's see, I want here. I'm just gonna use a Python module to serve the report. It's just easier that way. So this is the report we generated. The colors are based on how many people watched it, everything from 0, like Antarctica and the lighter areas in Africa, all the way to over 4 million hits in the US. So to answer our question, who's watching this? Yeah, it's us goofy Americans watching all this goofy stuff. What can I say? So let's see. Scaling. So JSR offers a number of scaling options, splits being the first one. A split, just like in Spring Batch, is running steps in parallel, right? So I've got flows that I can run in parallel. The JSR provides the same option. Partitioning is the other option within the JSR, but it is different. The concept within the JSR is you can execute chunks or multiple instances of a batchlet in parallel. In Spring Batch, it's only applied to the chunk side. We don't offer the ability to execute tasklets in parallel. The idea behind a tasklet is that it's a single executed piece of code. So we never really considered running them in parallel. Some of the people we talked to in the expert group thought it was a good idea. So you can run batchlets in parallel as well. There's two ways to configure it. You configure it either hard-coded in the XML, so you specify out partition 1 gets these parameters, partition 2 gets these parameters, and so on. Or you can use a partition mapper. If you want the Gunner's talk, this should be a review. But it was a partitioned step in Spring Batch has two components. A partition handler, which understands the fabric of which the data is being distributed over. So is it threads? Is it message queues? Is it something else? And then there's the partitioner, which understands the data and how to divide it up. The partition mapper within the JSR is essentially a partitioner. So it understands the data and how to generate the parameters that each partition needs to process the data. for those of you who are new to Spring Batch, how partitioning works is essentially you get multiple copies of the step, and each one of those copies executes in its own thread, and it is responsible for its own reading, processing, and writing. Each one of those copies gets its own set of parameters, so it knows what data to work on. So if I want to partition, let's say, a database table that has 1 million rows in it, partition 1 may get IDs 1 through 1,000. Partition 2 may get 1,001 to 2,000, and so on. Does that make sense? There are 2 additional concepts with partitioning that the JSR introduces. The first one is the partition reducer. What it does is it provides a hook for compensating logic. You have a multi-threaded step. If something goes wrong in one of the partitions, they want a way to essentially roll back everything else that was done. The catch, though, is really it's just a step listener or a step execution listener in the Spring Batch world. There's no difference between it. And in fact, if you use Spring Batch for your JSR implementation, whoa, sorry. If you use Spring Batch as your implementation, it's going to be a step listener. It's going to extend it anyways. The other things they introduced were a partition collector analyzer. The idea here is that the collector is a common way for batch artifacts to communicate back to a central place that can have an impact on the outcome of the step. So the partition analyzer would receive control at the end of all the partitions and basically be able to set the exit status. Again, it's just like a listener, or a step listener. Collector, like I said, collects data from batch artifacts. The analyzer allows the ability to set the exit status. One collector per partition, a single analyzer per step. Does that make sense? So we've had a few questions about Spring Batch's implementation of the JSR. First, let me give you an update on where we're at. I'm proud to say, with Chris's help, we released 3.0.0.m2 last night at about 10 o'clock. So it is available. It's out there. Check it out. It passes more than 50% of the TCK tests. And 3.0, when we go GA, will be JSR-352 compliant. I believe you two each had a question about how that's going to change. Essentially, the way we're doing it is we're developing this in a way that allows you the option, either the traditional Spring Batch route or the way the JSR is worded. So if you want to configure your jobs via the JSR configuration and launch them via the same job operator, or the JSR job operator, it will obey the JSR rules. However, if you have existing batch jobs, if you want to continue building Spring Batch jobs the way you have in Love up to now, nothing should change. Does that make sense?
I assume we can't mix and match. We have to go with one route or the other.
Buyer beware. So you just saw me create as close to a raw JSR implementation of that job as I could. So I didn't use Spring DI. I didn't use any of our readers or writers. Somebody, I forget who asked, they're like, doesn't Spring Batch already do that? Yes, it already does most of this. So when we look at this, I had to create 8 custom classes with over 800 lines of custom code. That's just Java code, that's no XML, and that also doesn't include any unit tests. Full caveat, that does include the 300 lines of mapping code, but still 500 lines of custom code to do that job. I mentioned at the beginning of this talk that there are 3 things that the JSR provides. An API for building components, a DSL for configuring them, and a contract for how they're supposed to interact. What doesn't it include? Components. It's a bunch of interfaces, right? You get no readers, no writers, none of the stuff, all the things that make your life easy in Spring Batch, you don't get any of that out of the spec. Spring Batch, you get a whole list of readers and writers, not to mention all the other things that these things can do. Let's take a look at the same app, Spring style. Oops. And I got like 5 minutes left, so we're going to make this really quick. Let me start off with the configuration, the Spring.
Is it right to assume that you guys provide a reference implementation for that JSR now?
The JSR didn't, IBM wrote a reference implementation for the JSR. IBM is a spec lead, they wrote the TCK and the reference implementation. It is open, the source is available. They don't take contributions to it, but you can check it out. So if we look at the batch job, this is a JSR batch job, so this is just used, all I've added is I'm using Spring components now in Spring DI, but I'm still configuring it using the JSR DSL, and I'm still using the job operator to run it. So here is the configuration. Zoom in a bit. So this piece is essentially the same. This is the job definition itself. What we've added, though, is a Spring DI to this. So instead of using my own custom batchlet for executing that split command, Spring Batch actually has a system command tasklet that I can just pipe in whatever system command I want to run, and it'll take care of all that threading and logic for me. So here I just say, I inject the same command that I have hard-coded in that batchlet, and it takes care of it for me. No code for that guy. In the second step, the reader, I'm just using the multi-resource item reader, which does exactly what we said we would do. It loops through a collection of resources and reads in all of them. It delegates as we go through resource to resource to a writer, or a reader, which in this case I'm using our flat file item reader. For the regular expression piece, we have a regular expression tokenizer. All these are standard Spring Batch components. So the regex line tokenizer, I just inject the same regular expression, and it does the mapping for me. The one piece of code I had to write so far, as we're going through the job definition, is I had to write a log entry field set mapper. So the line tokenizer piece of the reader takes the file and divides it into a field set, which is essentially a result set for files. The field set mapper takes that field set and actually maps that to the objects. So I did have to write a log entry field set mapper, which is really complicated. All but 10 lines of code. I had to format a date, just pull out the fields. The writer, so the processor is again the same processor we saw, so that hasn't changed. The writer, I'm just using the JDBC batch item writer. So here again, an existing component. I'm using bean properties to set the fields on my SQL statement. So again, no code here. And then the last piece is the report batchlet. Again, that's the same component I used in the JSR side. Does that make sense?
One question. Typical files, all like financial institutions, they have like file header, batch header, and all that. Spring Batch doesn't have direct support for reading such files. Do you have any plans or?
Which types of files?
File header, then batch header, then some records, then again batch trailer, file trailer.
For reading them or writing them?
Reading. So what do you have to do? Like you have to identify each line as whether it's header or batch, file header or batch header or detailed record, and then appropriately, so it becomes like multiple models.
Like, is there any way to read other than line by line? I mean,
So you can do multi-line reading, but to your specific point with the different record types, essentially, there is a pattern matching.
that's what we use. But,
Yeah.
but we have to make, for example, it doesn't valid. We have to validate it on our own. So that kind of stuff. So for example, if there is a batch header missing.
Because of timing, let's take this offline. Is that okay?
Okay.
Cool. Any other questions about the Spring version of this before we move on?
I actually have to run, but Adam told me to let you know that that's to be given away, provided by Manning, the book.
Oh, okay.
So,
All right. Thanks. That's not cool. Giving away the competing book. Seriously, dude? Wow. All right. Why is this? Why is this all jacked now? Oh, I know what. There we go. So as a comparison, really quick, the raw JSR, like I said, was 8 classes and about 800 and a quarter lines of code. 300 of those are the mapping, I'm being fully honest. The Spring version, though, is only 5 classes with 596 lines of code. Again, that includes the 300 lines. So you're looking at about 500 versus 200 lines, realistically. The big thing here I want everybody to take away, though, is JSR-352 is not a drop-in replacement for Spring Batch. There is, as you saw, there are no readers, there are no writers, there are no components. But there are so many more things that Spring Batch handles that the JSR does not. First of all, you get dependency injection. You get a robust way of building components and managing them. You get AOP, you get transactionality, you get all the things Spring Batch or Spring provides for you. Type-safe properties. Instead of having all strings and having to do all kinds of conversion in your code, you get real properties with longs and that type of thing. There's no inheritance within the JSR. So if you want to have a step that inherits from another step, or if you have a job that inherits from another job in Spring Batch, that doesn't exist in the JSR. That was actually a function that was originally in, but due to time constraints was pulled out at the last minute. Scalability. The JSR is single JVM only. There are no provisions for remote chunking or remote partitioning within the JSR. The only scalability option that the JSR provides is multi-threading. So if you can't do it in a single JVM, you're on your own. Whereas Spring Batch scales through multiple JVMs. That's what Gunner's talk was all about. We have remote chunking. So in this case, you've got a master-slave configuration. The master sends down the items to the slaves for processing. They're processed and then sent back to the master. Remote partitioning, all of the input and output is handled at the slaves as well. So the master only hands out the information needed, and then the slaves do all the work. Batch doesn't occur in a vacuum either. With Spring Batch, you can launch jobs via messages, via any of the Spring integration components. Whereas the JSR, there's no implied components on how to handle those types of things.
So that means you can mix sort of asynchronous and synchronous models?
Yes. Obviously, everybody's talking about big data. Spring for Apache Hadoop is built on Spring Batch. It uses Spring Batch. It provides tasklets to run your pig jobs, your Hive jobs, your MapReduce jobs. It's also a component within Spring XD. Spring XD builds upon Spring Batch and Spring integration to handle these big data loads. All these things are what you need to build batch applications within your enterprise. It's one thing to write a batch job that runs on my laptop in front of you guys. It's another thing to put it into a production environment where the difference between this running and failing is a pager call at 2 in the morning. Ladies and gentlemen, that's all I've got. Does anybody have any questions?
What's the way how the JSR handles transaction? How do you make transaction types of
There isn't anything within the JSR specifically for doing that within the job definition. Really quick, I'm supposed to give away a book. Who wants it? You were first. All right, he already has it. Pardon? Yeah, I'd love to give you one. Go for it.
Is there any plan to include a Spring Batch admin in Spring Batch?
Well, Spring Batch admin is independent. Actually, Spring XD has a lot of the Spring Batch admin functionality built in. So if you're looking for Spring Batch admin on roids, check out Spring XD. Cool.
Planning to attend the reactor thing, which is next.
Okay.
Would that be like using any of this?
Reactor is actually one of the runtimes for Spring XD. Correct me if I'm wrong on that. They're talking about using Reactor in some capacity within there, right?
Yes.
Yeah. So it's more of a Spring XD thing than Spring Batch directly. The things that Spring Batch is currently working on as far as bigger things would be Hadoop. Running Spring Batch on Yarn within MapReduce 2 is probably the next big thing for Spring Batch.
Can you elaborate a little bit
Definitely. I'm here all week.
So you guys are gonna be providing support for your own implementation of the JSR
Yes.
along with keeping to, so there's no fear of stuff getting, eliminated or, I mean, I'm just scared about the current batch jobs we currently have running.
We have no expectations of killing off any of that stuff. Thank you, everybody.